It was a regarded second when the Andromeda Cloud, for the present, changed into the Andromeda Endless System. The James Webb Telescope has seen 6 universes that exist a piece of a billion years after the enormous impact. This is mind-blowing when you truly take a gander at the night sky, making the rounds a pinpoint of light at the moment. That expanded gives you one of these photos from the Webb Space Telescope. It was a respected second as the Andromeda Cloud changed into the Andromeda World. For quite a while earlier, our perception of the Andromeda World was bound to base observations. In any case, with developments in headway and the introduction of the James Webb Space Telescope, our insight has created immensely. Now, things are going to change as the James Webb Space Telescope has perceived disturbing signs coming from the Andromeda universe. These signs have sent shockwaves through the scholastic community, leaving stargazers both motivated and inquisitive. Yet, what precisely do these signs mean? And why are they creating such an uproar among space experts? Join us as, only 2 minutes sooner, the James Webb Telescope shut down just subsequent to getting disturbing signs from the Andromeda Tremendous System. Already, we could see far beyond our eyes into the universe. Cosmologists confided in the smooth way for being the entire universe. This setback of data was fundamentally on the grounds of limited headway for seeing different endless systems and individual stars. In any event, things changed when we tracked down the Andromeda World. It filled in as our generally basic sign that the universe reaches out far beyond the smooth way. In the 17th century, Galileo Galilei's starting work with telescopes uncovered the smooth way's unquestionable nature. He saw that the smooth way had various stars, testing the winning thought of its particular significance. Everything changed during the 1920s when Edwin Hubble saw far-off objects beyond the smooth way using the Hubble telescope. Edwin saw that these brilliant objects, going through the universe, were universes, not the same as the smooth way. One of the structures was the Andromeda World, or M31. While this was the place where we initially saw the Andromeda World through a telescope, Persian cosmologist Abd Alaman al-Sufi first noted it around the 10th century. On record of mechanical kinds of progress in the 20th century, space experts could see and figure out the certified substance and embodiment of Andromeda. It is an indistinguishable cloud, including a tremendous universe of stars, like our smooth way. Our endless neighbor is around 2.5 million light-years from the smooth way. Since its discovery, the manner in which we center around Andromeda has, through and through, advanced. We have moved from ground-based observations through telescopes to space observatories like the Hubble and the James Webb Space Telescope. Each development in technology has taken us higher than at any other time, assisting us with figuring out the privileged insights of the Andromeda universe. We presently have more data and understanding into its creation and construction, making Andromeda a benchmark for considering the advancement of universes. This has uncovered a better understanding of the more excellent working principles of the universe. Researchers trust that to have an unrivaled view of our universe and the smooth way, we should zero in on the connection between Andromeda and the smooth way. This is particularly true considering that the two systems will undoubtedly crash in around 4 billion years. While studies and evaluations have advanced, the James Webb Telescope has recently gotten a disturbing sign from Andromeda. This disturbing sign confounds researchers, primarily inciting questions concerning its mindful beginning and potential ramifications. The James Webb Telescope's high-level sensors have perceived unusual developments just inside Andromeda's local area. The sign sent back to examiners shows results that differ totally from past observations, stunning researchers in general. The sign shows immense cycles occurring within the world, possibly related to its colossal black hole or recently disguised events. Strikingly, one of the most recent discoveries shows that Andromeda's mass might be much more significant than that of the smooth way, reshaping how we could interpret both endless structures. The James Webb Telescope has also provided detailed pictures and spectra of Andromeda, uncovering the development of new stars and their chemical compositions. This new information is critical for understanding cosmic development and the circumstances for life. Moreover, the information from the telescope suggests extended development in Andromeda's dynamic gas. This has, in the end, affected its surrounding climate and is supposed to shape its future development. By analyzing the gravitational effects on stars inside Andromeda, prepared experts gain pieces of understanding into the dispersing of perplexing dark matter all through the immense system. In a perfect world, this helps how we might interpret its impact on the parts at play in the universe. Figuring out dark matter and its influence on the universe is one of stargazing's most significant inquiries. Late forward jumps by the James Webb Telescope have inspired different examinations as experts analyze the insider facts of Andromeda. With more data becoming available, we now learn about its structure, past, and future. So, what have we found out about the Andromeda world through various assessments? Andromeda has shown essential attributes that differentiate it from different universes spread across the universe. Its sheer size commands thought, with late evaluations proposing a breadth crossing around 220,000 light-years. This figure makes it one of the most significant cosmic systems in the local group, much more significant than the Smooth Way. This tremendous expansion adds to its mass, containing an ordinary trillion stars, beating our tremendous system in star count. Research too sees the system structure as beguiling, unlike a customary winding structure. Andromeda has an extending center and a thick center encased inside rings of residue and gas. This is unquestionably a rich ground for tireless star development. Such highlights show a dynamic universe made by consistent cycles shaping its progression among its various parts. One of explicit interest is its center. It is described by a two-fold pinnacle discharge, showing the presence of a supermassive black hole, like, but not exactly comparable to, the Milky Way. This offers gigantic insights into the nature and activities of these gigantic matter-eating objects. The Andromeda Galaxy is similarly enclosed by a circle of brilliant junk, including stars, planetary, and globular clusters, crossing various gigantic amounts of light-years in extensiveness. This huge covering tells an enthralling, coordinated story of the galaxy's captivating beginning and history. The 460 globular clusters found in Andromeda likewise offer data into the arrangement of stars in their most memorable stages, giving a clear explanation of the development of star clusters and the early new developments of the universe. In sorting out the secrets of Andromeda, stargazers are the smallest bit closer to understanding the gigantic importance of dark matter. However, the demand holds up. How do they address its puzzling nature and the role it plays in the parts of immense structures? Andromeda boasts another distinct feature, its satellite galaxies. Its crown structure is composed of more than 20 smaller, endless structures, and some of them are going through streaming, denying their stars and gas. This cycle involves a more prominent galactic structure pulling in and annihilating neighboring negligible galactic structures. This shows the dynamic nature of massive development and describes how galaxies form and interact with each other over an extended period. So, what does the future hold for the Andromeda Galaxy? The shape and direction of its development interests cosmologists, as well as those endeavoring to comprehend the universe. The probability of its uplifting from a turning to a ring galaxy is a fundamental aspect in Andromeda's movement. Research focuses on a coordinated effort that could trigger other fascinating blends, perhaps from self-important impacts or close associations with other galaxies. If true, this suggests that Andromeda has encountered various relationships with other galactic systems since its first experience with the universe. Ultimately, Andromeda's future relies on the inevitable mishap with the Milky Way. As demonstrated by these models, the impact is estimated to happen primarily 4 billion years from now. The result of such an impact is the development of a new galaxy from these two massive celestial bodies. At any rate, it is a piece of respectable headway, in any event, to the immense distances between the galaxies. This boundless accident is unquestionably not a prompt, quick effect. After the impact, the two boundless galaxies would be substantially changed, illustrating new shapes and affiliations. The correspondence of their gases and residue will stir up new adjustments of star creation, instigating an enormous show above as the merging objects sparkle brilliantly. Ultimately, such a limitless event will result in the development of a single, round galaxy. This kind of impact is entirely expected, as the universe has a long history of such occurrences. In any event, quick interest makes it an event fundamental to us. Moreover, the normal accident of the especially giant black holes at the center of the two galaxies adds greater intricacy to the brilliant show. This suggests a puzzling and critical nature of massive development. The collision is expected to have influences on the matter being submerged by the black holes, which will emit wide radiation. This association offers huge information about how massive structures move throughout their life cycle and how black holes influence this development. In any case, it raises a vital question. What will happen to our solar system after this merger is formed? Off by far to an aggregate destruction of the nearby planetary system, the conditions of the nearby planetary system could change considerably. This suggests possible orbital shifts or even the launch of the newly formed massive galaxy. To understand this mechanism, researchers can focus on the scale of similar events occurring and contextualize the possible future of our own galaxy. It is important to understand that a collision between stars is an extraordinary event in space due to the tremendous intergalactic distances. Regardless, the gravitational change could shake stars' stable orbits, causing a few stars, including our Sun, to head in a different direction. Such a change could considerably influence the environment on Earth. Perhaps one of the most fundamental changes individuals could experience is moving farther from or closer to the Sun. This could incite either warming or cooling impacts. A hotter environment could cause ice caps to melt and sea levels to rise, while a colder one could ignite another ice age. On top of that, the change in position could hinder radiation levels from reaching Earth, creating altogether more challenging conditions. The Milky Way and Andromeda galaxies are bound for a close-to-miss impact, an event that will reshape the eternal landscape. This effect, estimated to happen in around 4 billion years, will be one of the most critical events in the universe's development. As the two galaxies move toward one another, their mutual gravitational attraction will start a shocking dance of colossal forces. The collision is not an immediate effect but a gradual merging process. During this cycle, the galactic centers will eventually merge, causing the formation of a new, consolidated massive galaxy. In the early stages of the collision, exchanges between the galaxies will trigger an extraordinary star formation event. The gravitational disturbances will compress interstellar gas and residue, lighting new star births. This starburst development will create a dangerous display of brilliant firecrackers, with infant stars illuminating the merging galaxies.